I'm going to do a Java program, and really program is not that difficult. I think some people have trouble in converting mathematical expression into Java source code. So I'm going to show you that. And there is a very popular method called substitution that can be used for that purpose. You may or may not have done enough math to know that, so I'm going to show you that. Again, I'm Dr. Satish Singha at Rose State College in Midwest City, Oklahoma. And I'm going to show you first how to convert a mathematical expression into Java source code, and then the loan payment Java program. Okay, so let's proceed. Okay, so we are generally talking about financial calculation formula, and financial calculation formula are often long and have divisions and power expressions, and generally bankers approximate them to simplify them. Let me get my pen for a second here. Pen, color red, pen. So bankers very often approximate them to simplify them, but there is a problem with that too, of course. In process of simplification, the accuracy is lost. However, calculation do become simple, no question about that. And as software developers and engineers, we cannot afford the inaccuracy of banker simplifications. Bankers use simplification just to give a basic idea. They don't use simplified formula to do exact calculations. They fall back to calculators and tables to do that. So we need to work with exact formula. Okay, so we must learn to use original and exact formula. That requires knowledge and strategy to convert mathematical formula to Java source code. Okay. For simple formula, it's not a difficult thing. You can easily do it. But when methods are part of the formula conversion, source code conversion, that might require a little bit of an effort. Okay, so we'll take one such formula which is used to calculate monthly payments on a loan. So let me talk about that just a little bit. Let's say you go to bank, you take a loan. So bank is going to have a annual interest rate applied to the loan and the number of months for which you will be given loan. And sometimes both are negotiable. Okay, so before monthly payment can be calculated, three things have to be fixed: amount of loan, annual interest rate, and then and that you'll pay every month, and then monthly payment can be calculated. Okay, and based on the life of the loan, there will be a certain fixed number of monthly payments. So if you take a loan for 3 years, your monthly payment will be 12 multiplied by 3, 36. If you take a loan for 5 years, your monthly payment will be 12 multiplied by 5, or 60 payments. Okay, all right. So this is the formula for monthly payment on a loan given below. So formula is actually in 3 lines. Left hand side is the monthly payment you will owe. Right hand side is on the top, the numerator has loan multiplied by, and I'm using 3 different type of brackets here, as is the common rule in mathematical expressions, although all 3 are used in Java but in different ways. So in Java you cannot use these for the formula, square and the curly, but this is not Java expression, this is mathematical expression. So inside the curly brace, which holds the numerator on the top, I have first term, which is rate divided by 1200. So rate is the annual interest rate in percent So if annual interest rate is 12%, then this will be 12 divided by 1200, which will be 0.01. Okay. And then the second part of the numerator is, notice the parentheses, rate 1 plus rate divided by 1200 to the power num payments. Num payment is number of payments. And then denominator part is this expression in curly braces here, minus 1 plus the same expression that I have here, 1 plus rate divided by 1200 to the power number of payments. Okay, and these are again described. So month PMT is the monthly payments due. Rate is the annual interest rate in percent. So if it's 12%, then it will be 12. Okay. Num payment is the total payments made by the user. And as I said earlier, if user took a 5-year loan and payments would be made monthly, the num payments will be 60. 5 multiplied by 12. So really number of payments, num payment is simply, if monthly payment has to be made, payments have to be made every month, then you just multiply by number of years, multiply by 12. Okay. All right. Let's see the simplification steps. It is possible to get user input for loan, rate, and num payments and plug into the formula directly. We can even do the Java source code directly. But for some people, simplification steps may help, and we are doing it for them. Best way to simplify is to use substitution method. You may or may not have learned that in math, but we are going to show you how that is done. And we show that substitution method now. So first, once again, that's my formula here. Left hand side we don't have to worry about. Simplification steps are really needed for the right hand side. And this is the numerator, this is the denominator, whole thing gets multiplied by the loan. Okay. So substitution number one is, in place of rate divided by 1200, which has appeared here, here, and here in 3 different places, I simply put a value called R. So meaning of that is, take out rate divided by 1200, replace that by R, and then I'm going to eliminate the unnecessary braces. So my formula then becomes this. So R multiplied by 1 plus R num payments, because this thing got replaced by R, so I get 1 plus R here to the power num payment, and since this whole thing got replaced by R, I get the R here. So this thing over here, okay, I got the next one, got replaced by R. This got replaced by R, so I get 1 plus R here. Num payments remain as is. At the bottom, this got replaced by R, so I get 1 plus R to the power num payment. The second substitution I do is, I say 1 plus R is F to the power, 1 plus R to the power num payment is F. So over here, this part got replaced by F, and at the bottom this part gets replaced by F. So really my formula then becomes quite simple, R F divided by, in parentheses, minus 1 plus F. Okay. And the way to do this would be really, don't just be a viewer, be a doer. Okay. Let me say that again, don't be just a viewer, be a doer. Pause the video here, write it down on a piece of paper, long piece of paper, and then do the substitution yourself, so you can go from here to here and see all the steps. So do it, don't just view it, do it. Okay. Okay, then we are going to do the Java source code translation for each step. and the source code. We show you the Java source code for each substitution step until we reach the Java source code for the final monthly payment formula. And we are showing that in a table on the next slide. So Java source code translation for each substitution step. So first step was that R was rate divided by 1200. This needs no translation really. All it needs is semicolon at the end. So I say R equal to rate divided by 1200. This does need a translation because in Java we cannot type this for power. We don't even have a head operator in Java. So basically I need to use math.pow formula, and we have demoed that in many different ways. It's a power formula in Java, and basically it has two parts, the base and the exponent. So when you do 1 plus r to the power num pmt, this is my base. So base is the first argument and num pmt is the second argument, and power formula pow is called by the syntax math.pow. Okay, so it's really that simple. If you want me to show you a few more things about it, I suppose I can do that real quick, impromptu on a Word document. Okay, and I may have to reduce the size of the Word document. Yeah, so and let me increase the fonts here. Okay, actually it's right here. We'll make font kind of big. So if I have a to the power, and power is generally used as a hat. Okay, let's do all caps. Then math.pow will work like this. First argument A and second argument B. Alright, so that's pretty much what we have here. First argument was 1 plus r, we put that here, and the second argument was num payment, so we put that there. So then going back to previous slide, this is really our formula that if you go back to previous slide, okay, previous, I think I should be able to do it with command, no, previous, yeah, this will be a little slow. This was my formula here, so that's finally I'm translating that one. Okay, there you go. So monthly payment, month PMT equal to loan multiplied by RF divided by minus 1 plus F will become, so for each parentheses you still need the asterisk sign, so loan asterisk, and the square bracket gets changed by the round braces, because in mathematical formula in Java we cannot use square bracket. So then we have R asterisk F, R multiplied by F, divided by minus 1 plus F semicolon. So this is the formula. You need to understand that in actual programs you will need to declare variables for intermediate substitution steps. So you'll need to declare not only variables for rate, num payment, month PMT, and loan, but also variables for R and F. And an RF data type for R and F would be what is on the right hand side. You can't escape this reality. Data type of this must be same as that, what this will compute to. Data type of this should be exactly what this will compute to. POW function returns a double type, so this will be double type. Okay, so you have no real freedom in choosing data type for R and F. Those will be dictated by that. And of course you have no real freedom for data type for rate, because then you have to decide what are the possible values of the rate and the loan and the PMT. Okay, we'll do that very shortly. Okay, so here's our data type for various program variables that we are going to use. Okay, rate has to be a double type because interest rate can contain decimalized fraction parts. I could have an interest rate of 7% or 7.2%. I can have interest rate of 12% or 12.5%. You cannot tell your banker that charge me interest rate only in round numbers. That's not going to happen. They'll probably laugh you out of the bank, basically, if you insist on that. The loan will be double type because loan need not be in round numbers or in whole dollars. Once again, you can say that, hey, I'm going to, even if you do, when you do the calculation, it's going to be in double type. So loan has to be in double type because it could be dollars and cents. Monthly payment is also, month PMT is also double type because the payment you compute may not compute to a round number. But this one has got to be a round number. Number of payments, hey, it's accountable. Number of payment 1, 2, 3, like that. It's accountable. So this has got to be int type. The program will work if it is double type, but that's bad software engineering. You don't want to use extra 4 bytes for something that's a round number. Okay? Sloppy software engineering if you use double type for num-PMT because it's going to be a whole number. So you must choose int type for that. R is double type because R is dependent on the rate. Remember, R was rate divided by 1200. Was it 1200? Yeah, yeah, 1200. So R will be double type. And F will be double type because math.pow returns a double type when its arguments are also double type. So F also must be double type. All right. So anyway, this should have been done before. This shows various data types basically. Okay, there are things we are not doing in this video. We expect you to do on your own the followings. After this analysis has been done and understood by you, you should do this on your own. Develop a flowchart for the program for loan payment calculation. Develop a pseudocode from this flowchart. Develop a handwritten Java source code where you're translating pseudocode to Java source code line by line. And then we will just show you the Java source code in the Eclipse. So we go to Eclipse, and if we have to come back to the PowerPoint, we'll come back, but I don't think we'll have to. So let's go to Eclipse now. So this is my Eclipse. I've already created my project, loan calculation. I do have an extra class here because I wanted to make sure that whole program runs before I show this to you or do the recording, video recording. Didn't want to make any errors during the video recording. So I'm going to be just kind of copying and pasting from this program to this program here. So my technique or my advice would be, depending upon how much experience you have, to whatever we did in PowerPoint. Okay, let's go back to PowerPoint. Let me actually escape this now. And go to whatever we did in this slide here. You should copy stuff to your Java file where you're going to be typing your source code, because sometimes it's hard to go back and forth. And if you have all the information in the source code under comments, life becomes somewhat easier. So we're going to do that actually. So first of all, we work with the variable to be declared, and I'm assuming that you are going to copy and paste them from your PowerPoint program, although copy and paste may not always work, it might. So first we need to understand the variables to be declared and initialized. So first variable we need to do is the scanner, because we're going to need user input for rate, loan, and num payment. Okay, so we do that first. And although it has been done, this one I'm going to do here by myself, because it's going to need an import, new scanner system.in. And of course you'll see this red line that will disappear if you import the scanner, which is done right there. Okay. This one doesn't come for free, it requires an import. Okay. The other one we have already decided, the rate, loan, num PMT. Num PMT will be in type. Monthly payment, R, F, rate, loan, these will be all double type. So since we have already made that decision, I just copy and paste that. You must initialize anything you declare. That's to avoid hassles and error messages, basically. So rate was double type, as we saw in our PowerPoint. Loan was double type. Num payments is number of payments countable on fingers or hands. So that's int type. Month PMT is the double type. R and F are double type. So all except the num payments are double type. Now we get the data. So we get the user data one by one. Generally, loan amount is gotten first, and each time we get a data, we feed back to the user what the data is. So we get the input, we tell user that enter the loan amount. We do give them the format so that they're not forced to think whether loan should be only in whole numbers, round numbers, or it can contain decimals. Okay, so format has to be given necessarily. And since loan is double type, I'll use the next double method. And then it is important to feed it back. That's good for you and good for them. It's also called echo printing. Feeding it back tells them that they entered the number correctly. So I'm going to just run the program right at this point, because I want to see that my line up to 25 work correctly before I code more. So we do run as Java application. Okay, I had this problem before in my Eclipse Java. Oh, actually I didn't save the file. I'm sorry. I have to save the file. It doesn't save it automatically. On Eclipse on Mac, for some reason, it doesn't actually. So that's the reason. So, okay, so here it says enter loan amount, right? So let's say my loan amount was $10,000.21, and it tells me you entered $10,000.21. Comma separators should not be used ever in data entry or when you make assignments. You're asking for trouble if you flow in that direction. Okay, enough said. All right, so now I get the next input, which is the interest rate, and I do the same thing. I tell them what to enter, format, and feedback, both. So here I say enter annual interest rate, example. So showing example is very important. If you don't show example, they may be confused. User may be confused. So I say if interest rate is 7.2% annually, it must be entered as 7.2. If it is 12.1%, it should be entered as 12.1. And then I take the input in the rate variable here, and I use keyboard.next double because rate is double type, as you see here. The type has to match with the method, input method. That's very important. Okay, and then I feed that back. And now I run my program one more time to make sure that these two inputs are coming out correctly. And actually, yeah, I have to save it again. Eclipse on Mac somehow requires saving each time. It doesn't save it by itself, unless I find a way to do it. So once again, I 10,000.21, and if my interest rate is 12.1 per year, I enter 12.1, and the program feeds back both, fed back to the user, fed back to the user. I need only just one more input, and then we are done with the input. The third input is the number of payments paid back. So once again, I ask them and the feedback. So number of payments input. So here I ask them, enter number of payments to be made. I have to tell them that this should be whole number only. Okay, just to avoid confusion, whole number only. Average user, of course, smart enough to understand that, but it doesn't hurt. You cannot make error in the direction of clarification. In my opinion, there is no such thing as over clarification. So if you need to make an error, make error on the side of over clarifying. Under clarifying could always be a problem. Since it's going to be a whole number, since we declared numpmt as int type, I use the next int method, the input method. Okay? And then I feed that back. And I save my file on Eclipse. On Mac, generally it's not necessary, but Mac you have to. And I just run my program one more time. So I'll enter 10,000.21, fed back correctly, interest rate 12.1%, fed back correctly. If I'm taking a loan for 3 years, 12 payments per year, my number of payments will be 36. Type 36, fed back correctly. Okay, so looks like my inputs are going correctly. Now I do my computations in the order in which my final monthly payment formula will require. I think you could see that from the PowerPoint, that first you calculate R, because R is the basic thing. Then you calculate F, because F uses R, and then lastly you calculate the monthly payment, because that uses F, R, and loan, all three. So that's the sequence. Okay, so we have done them in the same sequence. Set up intermediate computations, and then do the final computation. Okay. When you would have done all the things I asked you to do, you would already have a handwritten code for everything that I'm doing here. So intermediate computation was R equal to rate divided by 1200, which we saw that in PowerPoint right there. That was the first one. Then F equal to math POW function method. First argument 1 plus R, second argument numpmt, and that came basically because we converted this expression into this Java expression on the right hand side. and then we set up the final calculations. Month PMT equal to loan multiplied by parentheses or multiplied by F, that's on the numerator, divide by -1 plus F, whole thing parenthesized, and that really came from here. Let's see. Okay, here we go. Yeah, so actually it's right here. Yeah, exactly. So we have that right here, exactly. And of course, we did copy and paste that earlier over here. Okay. Novices will make errors in case and all those things, but you just need to develop a strategy that your errors are minimized. Okay, anytime you make a typing error, there will be red line, but there are no red lines here. Let's say I missed this mine plus, there will be red line then. See? And so you can avoid errors by making sure you are correct with each step. Now I just need to print my monthly payment. In a big program, you can do more. You can find out how much they total paid, how much with the interest, and all those things. We are kind of going to skip that for now. So just one result, and I'm gonna code that in. But your monthly payment will be this. Actually, I forgot the dollar sign. I can add the dollar sign, not a problem. And then it's very important to say goodbye to the user. So say goodbye. I think we should have said welcome also. If I didn't, I will do that soon. Okay, so did I welcome the user? I didn't, so let me just do that. Okay. There we go. Okay, so no red lines. Working on Mac, have to save the file. To run, right click, run as Java application. And I'll take some numbers that will make some sense, but also maybe some unrealistic number. When you go to bank, you will not ask for $10,000 21 cents loan, but I will, so that you know that fractional data are allowed. $10,000 1 cent loan, and the feedback gave me the correct value. Let's say interest rate is 12.01%, 0.01%, which will come out to about 1% per month, and the feedback is correct, this one. And let's say I'm taking loan for 3 years, so 12 payments per month, 12 multiplied by 3 is 36, so I'll have 36 payments. And the payment will be this number, although in ideal situation I should get only 332.19, I get these extra figures because double data type has to be masked to show you correct decimal points. That's done using a print method called printf. And we have not shown that. That's a whole different video. But I'm just quickly going to show you that here, that system.out.printf, and first argument will be this whole thing. But I will not explain that here. and this will be my format string, which is %.2f. Meaning is apply to decimal format to this here, which will be month PMT, semicolon. Save the file. So printf is a function in Java that can give you the formatting. I will not explain that in this video, but maybe in one of the future video. It's already in the ebook, of course. So let's run that now to give you dollars and cents. Okay. I don't know why I have this one here. Actually went away. All right. So I'll do the same thing. $10,000 and 0.01 cents. Interest rate is, let's say, 12.01, and for 3 years, 36. Okay, and my goodbye came on the same line, so let's just take care of that slash in here. So one more time. Not trying to be perfectionist, but just kind of wanted to make sure it came out right. Okay, so 10,000.01, 12.01, 36 payments for, that means 12 payments per year for 3 years. And now you can see that we are getting the rounded number. Let me actually copy and paste that here. Okay, so we entered, this is the loan amount, got fed back here. Annual interest rate, we are giving them the format, give the loan amount format also. 12.1, we fed back, it was 12.01, not 101. Here we tell them number of payment should be whole number only, so they do enter whole number, fed back. Raw monthly payment is this, formatted to decimal point using printf is this, goodbye. Okay, that's our program. If you need to see source code for any particular part, I'm just going to kind of go from top to bottom slowly, and you can pause the video and see it. These are comments and notes that I derived from my paperwork. Welcoming the user, scanner declaration, which will put the import on the top. Declaring and initializing variables. Here are the types declared. Getting inputs and feeding back to the user. Need the input for 3 things, and I feed back all 3 of them. Set up the intermediate calculations for R and F. Set up the final calculation for monthly payments. Print monthly payment as raw. Print monthly payment as formatted to decimal point, and print goodbye. Okay, thank you so much. I'll see you in the future video. Hopefully you will understand now how to convert from mathematical formula to the Java formula. There's a website I can show you for further practice. I think I had that on Safari earlier. Let's see. Might have it, might not have it actually. Okay, actually, I'm not going to worry about that now. I can tell that to you separately. Basically, thing to do would be go to web and type things like financial formula in the Google, and it'll come up with some formulas. try to convert them into Java source code yourself. Geometrical shape formulas, type that in Google and it'll come up with a whole bunch of geometrical shape formula and convert them into Java source code to get the practice. Okay, so that's how you should learn further on this topic. Thank you. Bye.